Okay, so like you saw on the website, this is a problem that you should have done on your own. So we're just going to go through it quickly and just to check to make sure that you got everything right. So we're trying to describe the sampling distribution for the proportion of orange M&Ms between a plain M&Ms and then also peanut M&Ms. So determine the shape, if it's normal or not, we do the condition where we're doing n times p and then n times 1 minus p. And remember, we have to do that 2 times, so 4 total calculations because we have 2 different samples that we're dealing with. So you can see the different calculations that are listed. It is all of them checked out. So we know that the sampling distribution is going to be approximately normal because it met that condition. So that's how we describe the shape of the sampling distribution. Next, we're going to go down and talk about the center. And the way that we're going to talk about the center is the mean. So remember, for the mean, we take the 2 different proportions and subtract them from each other. So P1 minus P2. In this case, it's going to be 0.20 minus 0.23, and that gives us negative 0.03. Again, it's really important that you're writing out what P1 and P2 represents because it's going to help you in your interpretation of the results. Okay, so for example, right here we have a negative difference of the mean. So essentially, we have to look at what that means in context with the problem. So since we subtracted the plain M&Ms first, and then we had the plain M&Ms first minus the peanut M&Ms, if we get a negative number, that means that the peanut M&Ms have a higher proportion of orange M&Ms than the plain M&Ms. Okay, so it's important that we label the P1 and P2 so we can understand what that means in context with the problem. Then if we go down and look at our standard deviation formula, those are the numbers that you should have plugged in, and your standard deviation should come out to 0.0374. Remember, for proportions, I want you to be rounding 4 decimal places each time. So 0.0374 is what you should have got for your standard deviation.